With this video, we're going to take a look at the first lesson under our next chapter. So I just call them Module 2 since there are a total of 6 weeks for this summer session. So section 4.2, it's called Systems of Linear Equations and Augmented Matrices. There is more questions than I am showing you here, but I'm just going to model some example problems so you guys can figure out the rest. First question on the homework says, writing the coefficient matrix and augmented matrix of the given system of the linear equation. So this is very easy. So we have a system of equation here. First, this question is asking what is the coefficient matrix here. So for coefficient matrix, you only look at the coefficients for x1 and x2. So on the very first row, the first coefficient is 6 and the second coefficient is 2. So I have the 6 and 2 here for the coefficient matrix. On the second row, x1 has 2 and x2 has -9. So 2 and -9 will be the answer for the coefficient matrix here. Now, the augmented matrix is when you actually remove x1 and x2 and then put this system of equation to a matrix, what does it look like? As you can see, the coefficient matrix just comes here immediately, and then you put a slash or you put a line, and then you put the values behind the equation sign. So the first line ends in 4, second line, excuse me, ends in 8. So this is what the augmented matrix for this question is. Question 2. Question 2 is the same idea, but we have something different here. We're going to again write the coefficient matrix and augmented matrix. So the first line, x1 has 6, x2 is 2. But when you look at the second line, x1 has 2. Since x2 is missing, you need to substitute a 0 for the missing value. That's how you find the coefficient matrix. For the augmented matrix, remember what you put here just gets to copy it down here, and then you make a line. First line ends in 4, second line ends in 8. So this will be the augmented matrix for the next question. Question 3. So we're going to just look at this one. Write the system of linear equations that is represented by this given augmented matrix. So we're going to actually now do the backwards now. So we have the matrix this time, and we're going to try to write it as an equation, and we're going to use x1 and x2. So we're just going to do the opposite. So look, so we have 8x1 plus 9x2, and that's going to be equal to 13. And then on the next line, we have 1x1, which is just basically x1, and 6x2, and that's equal to 5. So this will be the system of linear equation, which is represented by this matrix. For question 4, it's just asking us to do some row operations. Row operations is, it's important we understand what they're telling us here. It tells me that I'm giving you a matrix, and then on this matrix, do these changes. This is row number 1, so this is R1, and this is row number 2, this is R2. So it says that go ahead and multiply every number on your row 2 by -6, and then add it with row 1 values, and then what you get, copy them to R1. So here, R1 is changing with all this, but according to this expression, we're not supposed to change the R2. So R2 values will stay the same. So row number 2, 4, -7, -2 is going to stay at the end of the answer. So if you look at here, I put the answer down here, 4, -7, and -2 is staying because we're not going to change the answer. However, R1 is going to go through some changes. So let's just change the R1. R1 is originally 0, -2, 3. Now we're going to change these numbers. It says, multiply -6 and R2. So this is my R2 values, row number 2 values. We're going to multiply every single one of these numbers by -6. So 4 times -6 is -24. -7 times -6 is positive 42. -2 times -6 is 12. So, but we're not done. Now we're going to add these numbers by the row number 1 values. So this is the row number 1 values. This will be added with 0, so we have to pay attention that we're adding the correct positions. Second number 42 will be added by the second number here, -2. And then the last number we got, 12, will be added by the last number on the first row, which will become 15. And all these numbers will be copied to row number 1. So this is what our row number 1 looks like now. And then row 2 is not changing. This is called row operations. When you have matrices, you can make any changes you like to your rows. You can just change one row, the second row can stay the same. The whole reason we need to perform some row operations is because on the homework, rest of the questions are solving systems of linear equations by using matrices. I'm not super fond of solving equations by matrices, but this is what the requirement of the lesson is. So if you like to just solve these equations by another method that you learned in algebra class, I'm perfectly fine with it because I don't check the way you solve the problem. But I'm just going to model how you would solve this problem using matrices with 2 examples. And for the homework questions, you're free to solve them either by the matrix method or you can use any method you like. Okay, next question on the homework is solve the system of equations using augmented matrix method. Question says x1 minus 2x2 is -9, 2x1 minus x2 is 6. So first, we're going to write this system of equation as an augmented matrix. And we just learned how to do this with the first couple questions on the homework. So we have 1x1, -2x2, and it ends in -9. And then the second line is 2x1, -1x2, and 6 is the last number. This is the augmented matrix for this system. Now we're going to perform some row operations to change this matrix to this format. We will just get 1 and 0 on the first line, and we will get the 0 and 1 on the second line. And whatever these numbers show up after the row operations, that will be the system for this solution. It might take shorter to change these numbers to this format, or it might take longer. It depends on how your brain attacks on this problem. But eventually, so what can you do, for example? This one stays good here, and then, but this is going to change to a 0. So what my mind thinks is just multiply the all first row by -2. So let me see if I can actually write here. And here, if I just multiply this one, the first row, it makes 4, 18, and then I add them up by the root, 2 numbers now, which is 2, -1, and 6. If I add them up, I get 0, 3, 24. But it's still not in the format, and then I will just copy them to row 2 now. So row 1, 1, -2, -9 stays on the first row, but then the second row, I'm going to change it at 0, 3, 24. Now, remember, I'm trying to put them in the form of 1, 0, 0, 1, so it's not quite there yet, but I have to keep thinking. So I need to find a way to make this a 0. So I need to find this, make to a 0. Let's just go ahead and add these 2 rows first. So I'm going to copy the first one, 1, -2, -9. And then I'm just going to add these 2 rows and then copy them on the second row. So 1 plus 0 is 1, -2 plus 3 is 1. And then when I add the -9 and 24, that's going to be actually, if I think that's 10, I think that's 15. Okay, so 1, 0. So this didn't go very well. I have to change my strategy because I really wanted to keep this as 0. But again, if you just keep thinking, and then try your best to change this to this format, you will find that x1 is 7 and x2 is 8 for this question. But again, you don't have to solve with matrices. It's good practice that actually it's a good brain gymnastics that you think, how can I change these numbers to make them look like 1 and 0? Because you can perform an operation, addition, subtraction. You can even multiply them by fractions. But eventually, and when you look at the homework and click on view an example, they will tell you their logic, how they change these numbers to this format. I'm going to just model one more example before I finish this video, a similar question here. And then we're going to first write an augmented matrix, 3, 4, 1, 1, negative 2, 7. Again, our goal will be changing to this format so we can solve the equations. When you do the necessary row operations, the matrix is supposed to look like this now. So x1 becomes 3 and x2 becomes negative 2. And this is how you're going to handle section 4.2.